Hello students, let us start the new chapter, chapter number 10, Arithmetic Progression. Have a look at the examples which are given in the slides. There are some group of numbers which are arranged in a definite order. Look at the first example, 1, 3, 5, 7, 9. Identify the order which is followed in this group of numbers. The rule followed is each number is 2 more than its preceding term. Similarly, in the second example, each number is 2 less than its preceding term. In the third example, each number is 5 more than its preceding term. In next example number 4, each number is 3 less than its preceding term. And at the last, we have each number is a square of its preceding term. So in the above examples, what we have solved, 5 examples is written over here. So all these examples are in such a way that the numbers are arranged in a definite order. So what I mean to say is, if and only if the group of numbers which are arranged in a definite order by following a certain rule, then we call them as a sequence. The numbers which are used in a sequence are called its elements or terms. So here 3 terms we need to know in arithmetic progression. First one, it is sequence. Next one, it is elements, and then it is also known as terms. So what is sequence? So if a group of numbers are arranged in a definite order by following a certain rule should be same. So then only we can call them as a sequence. So each number which are represented in a sequence, they are called as elements or also terms. Now move to the next slide. Just observe the next 3 examples. 1, 2, 4, 8, 9, 30, 28, 54, 98, 2, 4, 6, 10, 12. They are also a group of numbers, but they do not have any definite relation with their preceding term. So they are not in a sequence. Consider the next example. Look at the example over there. The terms of the sequence are connected by using a plus or minus sign. So this is called as the series. So sequence and series means the same, but when the terms of the sequence, if they are connected to each other by positive or negative sign, we call them as series. So now which are the new terms we came to know? Sequence, elements, terms, and then series. Sequence and series means the same, elements and terms means the same. Move to the next slide. When the elements of a series which are written in a definite order following certain rule, we call them that as a progression. In other words, a progression is a sequence of numbers. It is a sequence. That means there is a rule followed in the group of numbers, then only we can call it as a progression. But a progression will be how it is a sequence of numbers whose each term is related to its predecessor and successor by a uniform law. That law is very much important. Depending upon the law, we are going to name what type of progression it is. This point will be still clear when you solve the problems of this chapter. So let us come to the point of arithmetic progression. So an arithmetic progression is a sequence of numbers in which each term can be obtained by adding a certain quantity to its preceding term. That means to say, if T1 is the first term, then T2 will be the second term. Always the first term is represented by an alphabet A. A is the first term of an arithmetic progression. In simplified form, now onwards we can name or we can write arithmetic progression as AP. D is the common difference. So when we look at the definition of arithmetic progression, there is a sentence called as each term can be obtained by adding a certain quantity. What is that certain quantity? That certain quantity is nothing but known as the common difference, which is represented by a variable D. What is this D? How it is calculated? So always D is the value of T2 minus T1, the difference of second term and the first term. It doesn't mean always second term and first term. D can also be equal to the any of the difference of two terms. It can be T4 minus T3, T3 minus T2, any term minus its preceding term. Move to the next slide. General terms of an AP. So what's the general term of an AP? If I consider T1, T2, T3, T4 are the terms of an AP till Tn. N is the nth term that we don't know what is the value of n. First term is always represented by A and the second term is represented by A plus D. Just now we have discussed what is D. D is a common difference which we need to add for the first term. So how do we get the third term? When we add D to the second term, that is A plus D plus D. So it is represented as A plus 2D. We can just make out the difference, children. First term A, second term means A plus D, third term means A plus 2D, fourth term is A plus 3D. So whatever the term which I want to obtain, D will be 1 less than that value. That means to say, if it is Tn, what will be the nth term? A plus n minus 1 into D. Why? Because for T2 it is n is 2, so 2 minus 1 is 1D. For T3 it is n is 3, 3 minus 1 is 2D. For T4 n is 4, so 4 minus 1 is 3D. That is why we say the general term of an AP as A plus D, A plus 2D, A plus 3D, and the nth term of an AP is A plus n minus 1 into D. So whenever we need to find out the nth term in the sense for the given sequence or the series, you might be asked a question to find out the fifth term, sixth term, eighth term, ninth term. In such case, we use the formula Tn is equal to A plus n minus 1 into D. So this much is the theoretical part which we need to know about an arithmetic progression. So an arithmetic progression is a sequence wherein the numbers are arranged in which each term can be obtained by adding a certain quantity to its preceding term. General term of an AP is A plus D, A plus 2D and A plus 3D, and the nth term of an AP is A plus n minus 1 into D. So let us move on to the exercise problems. Move to next slide. Exercise 10A. Question number 1. Which of the following sequences are in AP? Question number 1, 2, 6, 10, 14. In this problem, 2, 6, 10 and 14 are called as terms of the given sequence. The condition is that we need to cross-check whether the given sequence is in an AP or not. So find out the difference, that is common difference. Let us consider D1 is equal to T2 minus T1. T2 minus T1 means second term minus first term. That is equal to 6 minus 2, which is equal to 4. Similarly, calculate D2, that is T3 minus T2, that is equal to 10 minus 6 is equal to 4. If D1 is equal to D2, in this first problem, the common difference is same in D1 and D2. Therefore, the given sequence is an AP. Whenever there are such type of questions where we need to find out whether the given sequence are in AP or not, we need to find out the common difference between the given terms. I have considered only D1 and D2. Sometimes we need to cross check with all the terms. If now there are 4 terms, I can calculate D1, I can calculate D2 and I can calculate D3. So calculate the common difference for all the given terms, and then if the common difference what is calculated is same in all the cases, then the given sequence will be in an AP. If not, we can say that they are not in AP. Look at the second question, 15, 12, 9, 6. Here d1 is equal to 12 minus 5, that is equal to minus 3. d2 is equal to t3 minus t2, that is also equal to minus 3. So in second question also d1 is equal to d2, therefore the given sequence is an AP. Move to the next slide. Question number 3. 5, 9, 12, 18 and so on. d1 is equal to t2 minus t1, that is 9 minus 5, which is equal to 4. d2 is equal to t3 minus t2, which is equal to 12 minus 9, that is equal to 3. In this case d1 is not equal to d2, therefore the given sequence is not an AP. Similarly, solve the third problem or fourth problem also, as they are in the fractional form. Take an LCM while subtracting and cross check. In the question number 4 also, d1 and d2 values are not same, hence the given sequence is not an AP. Question number 2. The nth term of a sequence is 2n minus 3. Find its 15th term. Nth term is always represented as Tn. If Tn is defined as 2n minus 3, Tn is equal to 2n minus 3 is an equation for only for this particular problem. That is why it is said that nth term of a sequence, there is a sequence, for that sequence nth term is defined by using the formula 2n minus 3. Find its 15th term. So in the place of n, substitute the value of 15, you will get the value of T15 as 27. That means in this sequence the 15th term will be the value equal to 27, or in other way we can say that 27 is the 15th term of the given sequence. Question number 3. If the pth term of an AP is 2p plus 3, find AP. Instead of n, they have given it as p. So now only the pth term is given. We need to form an AP. How to form an AP? Let us calculate the first 3 terms of the given equation. That is, if Tp is equal to 2p plus 3, then T1. In the place of p, you substitute 1. So 2 1s are 2, 2 plus 3 is equal to 5. Similarly, T2 will be equal to 7. T3 will be equal to 9. That is, required AP will be 5, 7, 9 and so on. Question number 4. Find the 24th term of the sequence 12, 10, 8, 6 dash dash dash. In this problem, we need to calculate the 24th term of the given sequence. As we are solving the problems of arithmetic progression, it is very easy for us to apply the formula for arithmetic progression. But the next chapter is one more called as geometric progression. So in the question, if it is asked to find out the 24th term, 5th term, and if in the question if it is not mentioned whether the given sequence is arithmetic progression or geometric progression, before we proceed with the solution, we need to cross check whether the given sequence is in AP, that is arithmetic progression, or it is in GP, geometric progression. So once if you learn all those 2 chapters, that is chapter number 10 and chapter number 11, you will be able to identify. But as a matter of continuous process to have it as a practice, first you just cross check whether the given terms are in the sequence. That is, just observe mentally over there. 10 minus 2 is 2, 10 minus 12 is minus 2, 8 minus 10 is minus 2, 6 minus 8 is minus 2. So this sequence will form an AP. So I can solve this problem by using arithmetic progression formula. So value of A is 12, D is calculated as T2 minus T1, that is 10 minus 12, that is equal to minus 2. And what is the value of T24? That is, N is 24, we need to find out the 24th term. The value of 24th term should be calculated. So take out the formula. Tn is equal to A plus N minus 1 into D. Substitute A as 12, N as 24 and D as minus 2. Writing the formula and substituting the values of A and D is compulsory. Then in the next step, keep 12 as it is. 24 minus 1 will result as 23. 23 into minus 2, its product will be minus 46. So 12 minus 46 is equal to minus 34. Question number 5. Find the 30th term of the sequence 1 by 2, 1, 3 by 2 and so on. So as I told in the previous problem, now we are solving the problems of arithmetic progression. So you just cross check mentally whether the given terms are in an AP or not. I will proceed with the formulas of AP. So question number 5, value of A, that is first term 1 by 2, and D is T2 minus T1, 1 minus 1 by 2, that is equal to 1 by 2. T30 should be calculated. That means we have to know what is the value of 30th term. That means to say n is equal to 30. In the place of A, substitute 1 by 2. In the place of n, substitute 30. And in the place of D, substitute 1 by 2. So in the next step, 1 by 2 keep as it is, plus 30 minus 1 is 29. Into 1 by 2 is 29 by 2. Take out LCM as 2, common LCM. It is because they are like fractions. 29 plus 1 is 30. 30 by 2 is equal to 15. Question number 6. Find the 100th term of the sequence root 3, 2 root 3, 3 root 3. This problem is also solved in a similar way. Find out what is A, what is D, what is n, and consider the formula Tn is equal to A plus n minus 1 into D. Substitute the values of A, n and D. Simplify the equation to get the solution that 100th term is 100 root 3. Question number 7. Find the 50th term of the sequence. So sequence are given in the fractional form. So value of A is 1 by n. Value of D, that is T2 minus T1, is equal to n plus 1 by n minus 1 by n. So take the common LCM as n, denominator as n. Then numerator will be equal to n plus 1 minus 1. Plus 1 minus 1 gets cancelled. So the result will be equal to n by n. That value is equal to 1. Consider the formula. Tn is equal to A plus n minus 1 into D. After substituting the values and simplification, T50, that is 50th term of this sequence, will be equal to 1 by n plus 49. Question number 8. Is 402 a term of the sequence? Now it is a question of yes or no. We need to cross check. The given sequence is 8, 13, 18, 23 and so on. If it continues in this way, that is increasing order, whether do we get 402 term in this sequence? So what is the method to be applied to calculate this particular problem? So same way, consider the value of A as 8 and D as T2 minus T1, that is equal to 5. In the place of Tn, write down 402, that is the nth term, and we have to know, is 402 a term of the sequence? We don't know it is which term, that is n is question mark. So after simplification, we will get 394 by 5. So as 394 is not divisible by 5, we will not obtain the solution as a whole number. So that means to say that 402 is not its term. So we should get a whole number. It should be the 8th term, 9th term, 10th term. We cannot say 10.5 term, 11.5 term, 11 1 by 3 term. We cannot say it in that way. We should get a whole number to say it as it is this term belongs to this particular sequence. So as 394 is not divisible by 5, 402 is not its term. Question number 9. Find the common difference and 99th term of the AP. Sequence is 7 3 by 4, 9 1 by 2, 11 1 by 4 and so on. Consider value of A is equal to 7 3 by 4, which is equal to 31 by 4, and D is calculated by using the formula T2 minus T1. 9 1 by 2 minus 7 3 by 4, convert it into an improper fraction. 19 by 2 minus 31 by 4, that is equal to common LCM 4. 38 minus 31 will be equal to 7 by 4. So D is calculated as 7 by 4. Do the subtraction carefully, convert the fractions and take proper LCM and do the subtraction to get the common difference. So T99 has to be calculated. So in the place of N, it should be substituted by the value 99. Consider the formula Tn is equal to A plus N minus 1 into D. T99 is equal to 31 by 4 plus 99 minus 1 into 7 by 4. 99 minus 1 value is 98 into 7 by 4, that results as 686 by 4, that is equal to 31 by 4 plus 686 by 4, that is equal to 717 by 4. Keep the solution in the simplified form, that is T99 is equal to 179 1 by 4. Question number 10. How many terms are there in the series? This problem is little bit similar to question number 8. In question number 8, the question was to cross-check whether the given term belongs to the sequence or not. But question number 10, it says that 148, this is the term of the sequence, sure that. But we need to cross-check it is which term. That is, first term is 4, last term is 148. So last term is 148 means which term it is. So it is very easy to understand that we need to find out the value of N. Consider A as 4, D as T2 minus T1, 7 minus 4, that is equal to 3. Then value of Tn is 148, N is equal to question mark. As 148 is the term of the sequence, value of N, it will be equal to a whole number. You need not to cross check because 148 is the term of the sequence, it is accepted. Only we need to find out is it is which term, whether it is the 8th term or 9th term or which of the term, the number of the term should be calculated. So 148 is equal to 4 plus N minus 1 into 3. 148 minus 4 is equal to N minus 1 into 3. 144 by 3 is equal to N minus 1. 48 is equal to N minus 1. 48 plus 1 is equal to N, that is N is equal to 49. Therefore, 148 is the 49th term of the given series. In the similar way, find out sub-question 2 and you will get the solution that 1.1 is the 21st term of the given series. So as it is decimal value, while simplifying, I have converted a decimal values into fractional form just to make the simplification easier. If you are comfortable in doing the multiplication and division of decimal terms, you can proceed in your own way for simplification, only to make everyone to understand the decimal form is converted into a fractional form. Thank you, children. By this we have completed first 10 problems of exercise 10A. Thank you. Have a nice day.